Hello and welcome everyone. We're here today to talk about drafting and design at a one-year program at NSCC. For the sake of today, it is February 18th, 6 p.m. in Nova Scotia, a very snowy day for some folks in the morning time. If you guys are watching this back, we are here on February 18th, 2026, and we're going to talk a little bit about the mechanical drafting and design course here at NSCC. I brought with me some instructors and a student of the program, and we're going to go through what it is, drafting and design, the details. For the sake of today's video, I just wanted to go over just a couple things before we get started. For those who are watching, you guys are muted and you'll remain muted for the entire video. Your cameras are not able to come on for our webinar, although we'd love to see some lovely faces. You guys will remain muted and you'll have the option to have live questions. So I'll be monitoring the chat throughout our live webinar if you guys have questions. And we'll also leave some emails and some information for folks, as you can see down at the bottom here, recruitment@nscc.ca. If you have any questions that you might want to ask and you don't want to ask them live, that's okay as well. If you come up with some questions as we go through our material for drafting and design, and you come up with something that you want to ask later on, feel free to send us an email and we can try to answer those questions for you. I will start with some land acknowledgements, knowing that NSCC is located in Mi'kma'ki, unceded territory and traditional homeland of the Mi'kmaq Nation. Our relationship is based on a series of peace and friendship treaties between the Mi'kmaq Nation and the Crown dating back to 1725. As treaty beneficiaries, we recognize that we are all treated people, as well as recognizing our African Nova Scotians. So African Nova Scotians are a distinct group who have arrived 400 years ago, and from that time on, they contribute to the infrastructure and economic wealth of towns and cities that they helped build, but did not benefit from. So let us learn more about our respective communities. We're shaped by the historical contributions of African Nova Scotians and Mi'kmaq. For the sake of today's video, we're going to be talking about drafting design, which is located at our Ivany campus here in Dartmouth. If you can see here, our Ivany campus is kind of the hub for three of our campuses, so Ackerley campus, IT campus in Halifax, and Ivany campus. And for the sake of today's video, we will talk a little bit about Ivany campus and how it's specific to this program. But the main event is not myself, it is the folks that I've brought with me today. And I have some faculty along with some of the students as well, if you guys want to introduce yourselves. Maybe I'll start with you, Brooks.
Yeah, hi, I'm Brooks Snyder. I'm faculty for the Mechanical Drafting and Design program. And yeah, we'll get into it later. But
yeah, I'm Jason Cameron. I'm one of the other core faculty for the new program, Mechanical Drafting and Design.
I'm Sam Power. I'm a second-year student in this program and just here to give my input from a student perspective on this program.
Awesome. And thanks again for joining us. Here are some lovely photos and some ways to reach out to our faculty.
And just to kind of clear things up, so Sam is a final graduate or will be a graduate of the two-year program, CAD Technician Mechanical, which is transitioning into the one-year certificate program, Mechanical Drafting and Design. So that's why Sam is the second year, but the students coming in from now on will not be second years.
Right, and I'm sure we'll get into the details of it, but this is almost like a one-year program. It's almost like a two-year program squished down into a one-year program, from my understanding. Is that correct?
Yeah, I mean, we took quite a bit out to fit it into this, and then replaced some of we updated the program, so we're getting a lot more shop experience. We're doing some we switched up some courses to make it more more industry ready.
Right on. Keep on keeping on.
Yeah, so working in this field, so the goal, our product is engineering drawings, and there are a lot of different industries that have that need engineering drawings. So my background is aerospace. That's why it's first on the list. It's not because it's alphabetical, but Jason has actually worked in quite a few of the others. But even within aerospace, you know, that includes industrial robotics, that includes engineering consulting, that includes manufacturing. So there's a lot of overlap within the different industries, and you end up doing quite a bit. And the engineering drawings required are it's a very wide variety of types of drawings. As far as job careers and opportunities, there are a lot of companies in Nova Scotia looking for drafters and designers. We currently, with our second year grads, we have more jobs than students. So we need you all to sign up for the program in order to fill the jobs that are out there.
I'm sure that's music to a lot of folks' ears who are out there looking for positions and jobs. All right.
So this is just some logistical details, I guess. Projected growth. So the federal government does this analysis, and so we thought we'd include it in here. Basically, we're somewhere in between these two, mechanical engineering technologists and technicians and drafting technologists and technicians. We're somewhere in between here. So you can see projected growth 2025 to 2030. It's positive in both Nova Scotia and nationally, and that is, we're seeing that. We're seeing that already, and we've just entered that range of dates. So I guess, what do we do in school? So here's kind of the boring stuff. I've bolded, so these are program outcomes. We have program outcomes, and then the courses that you take are meant to get you ready so that as a graduate, you have learned to do each of these program outcomes. But you'll get different courses that apply to each of these different outcomes. So I've kind of bolded the main focus points here. So using CAD, we create 3D models and assembly animations. We do that for all of those different industries that we saw on the previous slide. Then produce and manage technical drawings. So that's our main product. The 3D models that we're creating, the assembly animations, those are made in order to get to the technical drawings, which is our product. Apply GD&T. None of you probably know what GD&T means. It's geometric dimensioning and tolerancing. It's basically nothing is perfect, and GD&T tells you how not perfect you're allowed to be. And it's a whole new language that you're learning that goes on to those technical drawings. We'll see a little bit of it in a couple slides. Use metrology tools. Basically, we're learning to measure parts so that we understand those symbols that we're putting on the drawings. We actually learn to measure it and make sure that the parts that are made conform to the drawings that we made. And then knowledge of engineering materials. So everything's made out of something. We learn about steel, we learn about aluminum, we learn about other materials. The program map, So as Caitlin said, we reduced down to 1 year. So in the fall term, you're taking 2-dimensional CAD fundamentals where you're in AutoCAD, because there are still some companies that are using 2-dimensional AutoCAD, and we want to be able to meet the needs of those companies. 3D mechanical CAD, so we're learning to build models. And I'm going to show some examples in the next couple pages to show what those actually are. Mechanical drafting fundamentals, so what do drawings need to look like? What goes on a drawing? Deciding what views you're using. Introduction to dimensioning and tolerancing, so that's kind of the precursor to the geometric dimensioning and tolerancing that I talked about before. It's how big does something need to be, and how not perfect is it allowed to be. Then one of the new courses, Machine Shop 1 and 2, that we take in, so Machine Shop 1 in the fall, Machine Shop 2 in the winter, that's actually getting into a machine shop and learning to use that metrology equipment to measure parts. It's learning to use some of the machines, the CNC, well, drills, lathes, milling machines, CNC machines, a water jet. I'll show some pictures in a couple slides. Applied math for mechanical drafting. So this is very much a math directed to what are the math needs for doing this job. So it goes, let's see. It starts with whole numbers, fractions, decimals, and it's going to be addition, subtraction, multiplication, division of those. Then we'll get to like percents. We'll get to measuring parts. So basically what you're going to need in the machine shop for measuring parts and calculating, dimensions and tolerances. And I think we get up to right triangle trigonometry, but we build up pretty slowly to get into that. We don't go much deeper than the basics of sine, cosine, and tangent of right triangles. If you don't know what that means, that's okay. Coming into the program.
And that's what I was wondering. We're having, this is a behind the scenes, but we're having like ongoing conversations at NSCC about emission requirements. Would you say if someone came to you and they said, I am not good at math, is it something that they can practice before they come into the program, something they should be practicing before they come into the program, or where's our emission requirements are to graduate high school to get into this program, but we know that some students, we want to prepare them. Where would you say your math level would have to be before entering?
I'm gonna answer that, and then I'm gonna go to Sam as a student, which the math has actually been reduced quite a bit from what Sam went through, but you can talk about what we've actually needed in the going through the program outside of the math course. But it's I would say my goal is that you're comfortable with numbers, right? That we're gonna, a dimension is gonna be, can you go to the next slide? Actually,
yeah, of course.
Yeah, so here, this is parametric 3D modeling. Actually, go to the next one.
Yeah.
Okay, so here on the right-hand side, we're showing a drawing here, and that top dimension there is 34 plus or minus 3, right? Which means that that dimension is allowed to be anywhere between 34 minus 3 and 34 plus 3, right? So it's kind of a, that's a a comfort level with that. So that dimension, when we measure it, has to be between 31 and 37. I don't, it does get more complex than that, but that's where I want comfort with that level of math, right? Or not of math, with numbers. Don't think of it as math. Think of it as comfort with numbers. Now I'm going to defer to Sam.
Yeah, I was someone who was like very okay with math in high school. I definitely didn't excel, and I haven't once found in this that I'm like in way over my head. And like if there's something that you didn't know, there's no shame in breaking out a calculator. Like as long as you're comfortable with geometry, like you're able to find the area of something, or yeah, if you're decent with geometry, I think this is perfect. Yeah.
Right on.
And I find I'll spend time like teaching the geometry, and then they'll go to Jason's class, and Jason will be like, "Why are you calculating that? Just draw it." Draw it in CAD and measure it, right? So there are multiple ways to solve a problem, and I think you get that between me and Jason, even though we both have bald heads and beards.
You want me to go back to the other slide, or you want me to keep it moving?
Yeah. We'll go through the winter term.
Let's see.
No, we want to go back 2 slides.
Oh, I gotcha.
To the program map.
There we go.
There we go. Yeah, and then we have industry relations there at the bottom, which is that's going to be building a portfolio out of the work that you're doing in your other classes. It's going to be building a resume, right? It's basically it's those job skills or interviewing skills. You could call it a communications course. It's basically getting you ready to go out into industry, getting you ready to go out and apply for jobs, interview, get the job, and then enter industry. Then in winter term, basically we're taking all of the things that we learned in fall, and we're going into more advanced details of those things until we get down into specialty drafting and structural detailing. And in those cases, instead of going deep into the material, we're going broad and learning different types of applications of how we can use our skills, our fundamental skills.
Okay, I'm going to keep it moving.
Jason, you want to talk about these?
Sure. So just a little background on me, not a whole lot, but I graduated from an earlier iteration of this new program, which was actually an earlier iteration than the one that Sam is graduating from. And a lot of it, well, all of it was 2D, but half of it was pencils. And even though I took a drafting course with pencils, I've never had to professionally use a pencil to create a drawing. And if you look at my face, you might say, wow, that was a long time. I'm not that old, I just look that old, but I've never had to actually draft with a pencil. And when I was in school, we were discovering 3D modeling, right? We were finding clever ways of using the 3D modeling to create 2D drawings because it's just easier. You still have to have an idea of what it is that you're trying to create as an end result. It's just getting to that end result is easier. Since then, we've now come up with the development of parametric CAD. And just to kind of boil that down into the most simplest term, CAD means computer-aided drafting or design. And parametric just basically means that every number that you put into the CAD software is maintained almost like a spreadsheet, like Excel. So that any point in time you need to make edits to a number, you can just simply change the number and things just automatically update. So the concept of parametric CAD is you basically do sketches similar to what you see in the diagram on the left. This is actually a program that we use called Autodesk Inventor. You basically create basic sketches. You then perform operations on it. In this particular case, we're doing an operation called a revolve, which creates this cylindrical shape, which you see then in the figure on the right. And then from that, we can then automatically generate all the 2D details we need from the 3D model, with the nice benefit that when somebody comes to us and says, the dimension that you see there that says 9 on the left, it's actually supposed to be 10.5. And we can literally go into an Excel sheet of data, change the number, and it propagates right through the entire design phase, the 3D model, any drawings, anything. So that's kind of the concept of parametric 3D modeling, right? And we do a lot of that. That's kind of the foundation for our main output, as Brooks mentioned, which is those engineering drawings.
Right on. Do you want me to talk about this one, or you want me to keep it moving from?
Well, and this is obviously the next logical step. You have your 3D models, and then we create, in essence, what was traditionally those 2D drawings that somebody would have to actually draft with a pencil. But we're doing it using the tools that automatically harvest the 3D models for all those 2D views, and then we can just simply print it off and hand it to somebody, just as if we had drafted it by hand, right? And that's still the norm in industry to have 2D representations. To kind of put it in a kind of an easier way to understand, as CAD technicians, what our job is we're very much the people that are have a foot in two worlds. We work with engineers and designers, and we're designers ourselves to come up with the ideas. But we also need to translate those ideas to a manufacturing shop so that they can actually be manufactured in any way that they need to be manufactured. We are the translators. We learn a language in this program, and then we learn to communicate using that language. And that language is engineering drawings.
Okay. I have a question for Sam here. What gravitated you towards drafting design or this kind of field, this field of work?
Right out of high school, I was someone who didn't really know what I wanted to do. I worked a job where they had me taking apart some small engines, and I was often like referring to parts diagrams, so that kind of made me familiar with this world. But to be honest, my dad actually recommended me this program, and I joined this webinar 3 years ago, I guess, and yeah, it seemed interesting. Yeah, that's my story.
I appreciate it. I just know that there are some folks from home who have obviously clicked on our webinar or live today because they have that same interest. So it's always good to hear that perspective.
Yeah, I had no experience with 3D modeling, so don't think you need to have a foundation of it, because you really start from scratch when you come in.
Great.
Yeah, and this, if you go back one, sorry.
Yeah, yeah, no worries.
This is kind of, I put this in because this is kind of our two products, right? I said before that the engineering drawing is really our product, but it's getting more so to be that the model isn't just an avenue for getting the drawing, which it has been for so long. That model right now could go into software and then be 3D printed. That model could go into software and go right into a CNC machine, right? So there's a lot of data within that model as well that doesn't just get us to the drawing, which is, 20 years ago, that drawing is what a machinist would be holding in their hand. Now they might be holding an iPad in their hand and working with that model directly to create the G code, which 3D prints or runs the CNC machine.
Where the drawing then becomes the check for the output.
Right.
So the drawing is still very important to the process, but it sometimes isn't the thing that's driving the manufacturing. It's confirming that it has been manufactured correctly.
Right.
All right. So you guys are seeing if things are even possible to begin with, where the odds are, and if you guys are bringing some ideas to life.
Yeah, so these are some pictures of our Design Innovation Center. So when I talked about that Machine Shop 1 and Machine Shop 2 course, we actually get out onto the shop floor and use some of these machines in those courses. So this is on the left-hand side is a CNC lathe that stands for Computer Numerical Control. So basically, you're putting a code in there and the machine knows where to put the cutting tool as it's spinning. It knows how fast to spin it. Well, you tell it how fast to spin it. And then the cutting tool goes in and follows where you tell it to go. On the right-hand side is the water jet, which uses water with little particles of sand in it at a very, very high speed to cut through metal. So we're going to use both of those things. We can go to the next slide. And then measuring. So here we have a dial indicator on the left-hand side that is set up to measure runout, which would be what we learn in geometric dimensioning and tolerancing. And on the right-hand side is a CMM. So I know it's a lot of acronyms. We had CNC for Computer Numerical Control, and this is CMM for Computerized Measuring Machine. Did I get that right, Jason? Something like that.
It does measuring.
Yeah, it measures things.
You guys know how to
Very,
use
very,
it.
very
That's the most
precise.
important part.
These are some student projects from a few years ago. So this is an underwater 360-degree camera. So our student designed the whole casing that was waterproof that could put this 360-degree camera underwater, provide it with battery power, and deploy it under the ocean. That was done for the Oceans Research Center before they became CTAC, which is part of our applied research team here on campus. And this is a animated 3D model that some of our students created. They did all of the 3D modeling here, but their design was for the ballast system. So you can see where all those weights came out of there. That used to be on, that pin used to be a hinge point where it would open up. But when that happened, some of those weights would stick in the top side. Some would stay in the bottom, some would open up and stay in the top, and then they would fall out. And you're on a boat, it might be January, and those are spilling out all over the boat, and it's freezing cold, and you've got these giant mittens on, and you have to go find each of these ballast weights. So our students designed this to solve that problem. And part of this is, we are the one-year program that kind of goes alongside of the two-year mechanical engineering technology program. And the major difference between those two programs is that we are designers and drafters, mechanical designers and drafters. They are mechanical engineering technologists. So they're doing engineering design where we're doing mechanical design. What I mean by that is they would go in and try and make this as efficient as possible. They would, this is a problem that doesn't require a lot of math to fix. It requires some creativity, some thinking, some making sure things fit together right. That's what's needed here. It doesn't require a lot of analysis, right? And finite element analysis or a lot of software time and math and calculus. This doesn't require that. So there's a lot of design that doesn't require that, and that's kind of where we are. We'll make all of the drawings for the things that they're doing their engineering design for. We're happy to do that, but when you get into things like my background in aerospace, if it's flying on a jet engine, it has to be very, very lightweight. It has to be efficient. That requires engineering design. And so we would hire mechanical drafters and designers to make drawings versus, a company that creates these ROVs might hire mechanical drafters and designers to design, right? So it kind of depends on what industry you get into, whether there's a lot of calculations required for this type of design or there's not. And there's a lot of design out in the world that doesn't require a whole lot of analysis. And that's where we fit in the design world. We fit everywhere on our drafting side, except architectural. That's its own program. So some of the program requirements, and this is true for almost every program at NSCC, a 60% or higher is required in all of your courses. You'll get tests, assignments, projects, presentations, design reviews, so a lot of different types of evaluation. But we build you up to that stuff. All courses are learning outcome based. So what that means, and that's true again of all programs at NSCC, you might have passed the course numerically. You might have a higher than a 60%, but if you haven't met all the outcomes, then it may result in an incomplete, which we can get into policy later on. That can still be a pass, but you have a certain amount of time to get it there. Attendance and participation is key to your success. Can't stress that enough. You can see Sam nodding his head. Like I say on day one, show up, do the work, communicate. Those are your 3 responsibilities. And it's true. Everybody here is rooting for you, but you have to do the work. You have to show up and do the work. Portfolio is very important. Even just having it in the back of your mind as you're doing your projects. Your portfolio is what you're going to send out to industry to say, look what I can do when it's time to go get a job. And then work experience. So Sam has already secured his work experience starting in April. It's a 5-week mandatory work term that you're responsible for securing that employment yourself, but certainly with help from us. It's not our responsibility to get you a job, but we definitely help provide those opportunities for you to go to connect with industry to get a job, which is the goal, right? It's the goal from day one, get a job.
And correct me if you're wrong, if I'm wrong, it is the student's obligation, it's a responsibility to find their placements. But I'm sure you guys have so much experience that you've built relationships with industry, with folks who are in the work. And some people might ask you for a reference, right? So, and you guys can do nothing but be honest. So if you show up, like you said, show up, do the work and communicate, then that increases students' chances, I would believe, and you referencing for them, saying this is the person that I would refer to this job. Or if someone is on the other spectrum, maybe you are not referring them to that position or that job.
Yeah, and usually it's I mean, that would be a conversation where we would say, it's probably not a good idea to put me as your reference. Or here's what I'm going to say. It's up to you. If, you know, I'm going to say that you haven't shown up. You know, you show up 3 days a week. You're supposed to be here 5 days a week. You know, we don't grade on attendance, but your portfolio will suffer. You know, we're very active within the program. We're doing a lot of stuff. It's a lot of hands-on. And in the old program that Sam is graduating from, and in the new program as well, you know, the key is to learn. You have to learn something. You have to do something. And so if you're not here, you can't do it. Right? We're not trying to be power. We're not. Sam will be a testament to me hating power play. It's a necessary evil, but I don't like it. I don't enjoy those days.
Yeah, I'm sure if you show up and you put in the work, then you'll be happy to vouch and say this person is the right person for the job.
Textbook equipment and tools. So we're revamping our textbooks. So it is going to be quite different. But I like the new ones. Anyway, there's a link there to the program page that gives a basic cost of textbooks and other supplies. So there's, I think it's somewhere in the neighborhood of, I mean, this is going to be on YouTube forever, but currently it's somewhere in the neighborhood of $580 to $600 for the textbooks for the entire program. There is a computer listed on the costs. It's not mandatory that you buy your own computer. We have computers on campus. We have a typical lab that we are in that meet the system requirements for Inventor. The drafting kit is currently on the website as $50. I'm going to be reducing that. I'm going to be taking some of the stuff out of that. It's basically, if you come to me on the first day or request, I'll tell you what you need to have. It's like a ruler, a protractor, a good set of pencils that are different specific weights of lead, and then digital calipers. Those go, you know, I always tell students on the first day, don't buy these right now because in 2 weeks they'll be on sale. About 2 weeks into every semester, every September, they go on sale for 50% off at Canadian Tire. So this is out there forever, me saying that now. And then there's a link here to the drafting and design page. I don't know why I put all these links in here for this to go out on YouTube.
They'll be able to find it. I know who's watching live, or maybe they're watching back on YouTube. You get the bonus of knowing the details of purchasing or when to purchase. So you guys have done the homework of being here and listening, so you get the little details there. I like that.
Don't buy anything in advance. Wait till the
That's
first
good.
day.
I was gonna say that's a good point. Just in the air, like working in recruitment and having prospective students always reach out. Of course, they want to be on the ball. Maybe they're a little anxious about school starting up. Is it okay? And I know every instructor is a bit different, but based off of my conversations with instructors, the expectation is that you do not have to have every piece of equipment, every textbook for September, the very first day. It is okay. Is that the same scenario?
Yeah, but don't, once that first day hits and we firm up what you need to have.
Yep.
Then that's, I mean, buy it.
And I think that's some of the like overlaying conversations and communication that goes out with NSCC as well. It's like that first day, okay, I'm in business admin or I'm in whatever program I'm in, the instructors will say, yes, we're expecting you to buy that, or we're using open book resource, or so. Okay, great.
I might, if I can add something as well, as far as buying a computer, I don't have a laptop. And when I was registered, I was thinking I should probably get one to come to and from, but I would actually advise against doing that if you're considering buying a laptop for the program. Like I just have a desktop computer at home and it's been so convenient just coming back and forth. Like you can get access to all the software at home. If anything, the people who are bringing their own laptops to class are having more technical difficulties than the people who are just working on the computers in school. It's easier to just do that.
There you go. So the folks who are home with the computer setup, keep your setup, of course. I did want to mention that we do at NSCC do a laptop loan program through our library. So there are students who can loan a laptop for a semester. That semester ends, you can ask to renew it for the second semester, but that's all through our library as well.
Typically, those don't meet the system requirements for
Good to know.
for our software.
They have a few that will, they go quick.
Okay.
You need to borrow a laptop from the library. You might want to do that the first day and just see if you can get your hands on one, because they do go very quick.
Okay. But you guys mentioned that you have laptops in your classroom to use as well?
No, we have desktop.
Okay.
Desktop workstation.
That's right. Okay.
Yeah.
Perfect.
Workload and evaluation. So there are, you're going to have assignments, you're going to have group work, you're going to have project work. You're going to have presentations, tests, projects. The workload, I guess I'll jump down to that last question. Am I able to work part-time? I would say absolutely. I mean, I guess it depends on your and I'm going to defer to Sam again at the end of this. Depending on your time management skills, and if they're not good, it's a time to work on them. But if your time management skills, we never assign something and say this is due tomorrow, right? It's usually a week in advance, at least. And we give there's a lot of time in between classes to get things done. I didn't show a typical schedule, which is something we usually show in presentations like this, but it's because it's a new program and we have, I think, 7 courses per semester. So we don't have a schedule that's representative of that because it hasn't happened yet. But there is a lot of overlap between the courses. If I'm teaching theory on drawings and Jason is teaching the CAD for drawings, you might have one assignment due that incorporates both theory and the CAD for that. So we try to do that as much as possible. Sam or Jason?
Yeah, I would say it's all about just balancing your workload. Like I worked part-time through my whole first year. Not right now, just to like put a little more time into school, but as long as you're showing up, and like I find I don't have that much homework either, just because I'm getting it all done at school. And I'm not sure what the new program will be like, but a lot of in-class time is working on projects and assignments, which is nice. You know, you can get a lot of your stuff done in class. But yeah, you could work part-time for sure.
Yeah, and I guess if your definition of part-time is you're working from 9 to 4, that kind of schedule is unfortunately not going to work with the program. But if you, for instance, you know, you have a few hours every night or something like that, there's definitely flexibility to do this program. Yeah, but there is an expectation, you know, to be in class during the day when your classes are on as much as possible. And any time that you can't go to class, you are making an effort to check in with your, you know, your co-students and whatever else to try to make sure that you're not, you know, getting overwhelmed in your workload. So we try our best to strike a good balance, but every person's going to be different too. So
yeah, Jason, you brought up a good point. With the audience maybe not having attended NSCC before, most of our classes are between 8:30 a.m. and 5:30 p.m. Monday through Friday. So if you're scheduled for work outside of that, you'll be good for the foreseeable future. That could change, but I don't see it changing soon.
Yeah, that's a good point, because it is possible to work part-time, and it's going to be different for every student's situation, but also there's a responsibility for our instructors to get our students industry ready within the year. So you can expect a lot of work within the hours of you spending your time and assignments, and like Sam said, doing your work while you're in between those lines of school, 8:30 to 5.
And I should say it's not 8:30 to 5:30 Monday through Friday every day. There are a lot of breaks in there. Sam, I don't think your class has ever gone past 4:30, but it's leaving that range available for school work, scheduling work outside of that. You'll be fine. This is pretty self-explanatory. You need to graduate high school or equivalent for admission requirement.
Yeah, so a lot of our programs, and then this is an ongoing conversation, as I mentioned before, at NSCC about our admission requirements are for you to graduate high school for a lot of our programs, and that's why webinars exist, and having a little more in-depth understanding of what that means is always great. We talked about math. We talked about your comfort level with math. Again, this is not to scare folks away from the program. This is not to say anyone can come in, of course, but it's to give you guys a realistic expectation of what it is to be in the program. So yeah, high school graduation, of course, in order to get into the program. But again, you can start with, I would want to say, no knowledge of the program and get yourself where you need to be within the year.
Yeah, absolutely. We've had successful people who came in and they were like, to the computer-aided drafting technician mechanical program, they were like, I am not good on computers, and they've put in the work, and you know they showed up, they did the work, and they were successful.
Right on. I believe our last slide is about campus housing. For those folks who are watching right now, Ivany campus actually opened up their student housing in September. So this was almost going on somewhat, almost a full year of the academic year of being in student housing. 200 beds are available. Student housing is a separate application from your application to the program. So typically our applications are opened up all year round for the program. Applications are opened up now. I believe seats are still available for this program if you wanted to start in September. but our student housing is a separate application which opens up March 2nd. So anyone who's watching now, and if they are wanting to get into student housing, that application opens up March 2nd. As I mentioned, student housing is available around, I believe, 6 of our campuses out of our 13 physical campuses across the province. And we're working always on bringing more student housing to more campuses as we get dedicated funds. Someone is cleaning the floors here. Sorry for the beeping. I left my email, but this is a way to contact me. We have our instructors' emails at the beginning of this. So if you want to go back and take a look, actually, I can show it here. The lovely photos. If I go back and I skipped, I believe we'll go back to that. So our instructors are not obligated to, but it is very nice for our instructors to leave their emails. If you guys had very detailed questions about the program or something that you missed out on or didn't get to ask within the live webinar, they may or may not regret putting them there, but send them an email if you have those questions, or if you have questions for me, I have my email there. I just quickly wanted to touch on tuition because I know I skipped past it. At NSCC, our tuition is $3,620 for our domestic students. And we have a full list of programs on our website that are eligible for postgrad work permits for those who are interested. Drafting and design is not one of the ones that is eligible for postgrad work permits. Obviously, still an option if you guys would like to take the course and take the program. But I always want to say that. Right? For our international students, yes. So if anyone is here international and they're looking to get a postgrad work permit from the program, we do have a list on our website that'll delegate all of our programs that are postgrad work permit eligible for those who are looking for it, and ones that are not. It's always nice to know because I know we do have folks that are tuning in from different time zones and different spots. I do have one question. Someone in the chat asked if you could work. I know we talked about a little bit about it's different for every scenario, but someone asked if they could work full-time and participate or take the drafting design. Have you had a student in the past maybe work full-time? Again, we mentioned that you're expected to be in class 8:30 to roughly 5:30, and that's kind of worst case scenario. But I'm not sure where someone could fit in the full-time. But if you want to,
I would lean towards no. I mean, I guess like a full-time overnight job, but I don't know when you sleep then. Hopefully not in class. I know it's an investment but that's kind of true with the majority of our programs at NSCC, unfortunately, is that it is really hard to maintain a full-time job and come to school. I would lean towards no.
Yeah, the truth is this is a new program. It is not blended. It is not online. It is a face-to-face practical application of learning and applying the skills. And it would be difficult, if not impossible, to maintain a full-time daytime job and attend classes.
Yeah, and again, not to scare some folks away, realistic expectations again, and their job is to get you ready within that year for industry. So I know it's different for every kind of situation, but I think if anyone there is watching from home, wondering about part-time, full-time, these are the answers that we have for you. So.
And it says 1 year, but it's really not. It's September, 1st of September through mid-April, and then you're back out in the workforce, right, on your work term. So if you come in September through April, you work hard and connect with the right people, get a paid work term, secure full-time employment. We have 3 students now, or we have 2 students now who have already secured full-time employment once they graduate, or sorry, not once they graduate, instead of starting a work term, they're starting full-time employment as soon as we're done with this semester. So that counts for their work term. They will graduate based on that, but that is a full-time employment. That is full-time employment. And, you know, that's, with the new program, you're taking, what is that, September, October, 8 months, right? It's not even a full year, it's 8 months, but.
Yep. In my opinion, that's a good sacrifice to obtain your full-time job and get yourself. Another person had asked, is this only available at IVNY campus? And yes, so drafting design, mechanical drafting design is only available at the moment, and there was not any talk other than it being solely at IVNY campus here in Dartmouth. NSCC is always adding new trades or basing our what we offer based off of demand. So that's not to say that in 2 or 3 years that this is offered at multiple campuses, but at the time right now, it's only available at IVNY campus.
That being said, there are many employers outside of Halifax Metro that are looking for employees in mechanical drafting and design. And I just had a meeting last week with the general manager of McGregor's in New Glasgow, and it's hard to get people who've grown up in Halifax, Dartmouth, HRM, to move to New Glasgow, right? So same thing in Sydney with, say, Protocase, right? We've had trouble helping them fill their jobs, and they're looking for employees. You know, so from all over the province, we have companies looking for our graduates, and a lot of times it's hard for people to make that move. So if you're coming from out of town, and want to go back, you should reach out to us, and we can let you know of some opportunities that exist. And at the same time, with campus housing, you know, get in early and try to secure a spot in campus housing, and that makes that part of the transition much easier, because then you're leaving a place to come here temporarily, you have housing, and you have a place to go back to, in theory, right? So I'm just throwing out opportunities.
Mm-hmm.
They do exist, and we have had trouble filling those industry needs because of cost of moving and things like that. So even though we're only available here in HRM, there are companies looking for people, looking for our grads.
Someone's asking what a starting wage would look like upon graduation.
Good question. That has, I think we're around $25 an hour at this point, which is kind of an average. Now that's, you know, $25 an hour, $25 to $30 an hour is kind of the, I wouldn't say that for work term. For work term, I'd say somewhere 18 to 25, and then after work term, 25 to 30. That work term is really kind of a trial it's kind of a probationary period for you as an employee, but also for them, you're trying them out as much as they're trying you out, right? So after that, and that is kind of a big range. It kind of depends on the company. You know, if you're at a smaller startup, it's probably going to be lower. If you're at a big company, it's probably going to be less negotiable. So that's where Yeah, that's where I'm at currently. I don't actually have information current to this year. I'm basing this on last year and before, because we haven't really gone out to the workforce yet this year. But
it is very much an industry that rewards skills. So if you excel at what you do, you will get a raise. It is very performance based. So, but I've even seen like entry, wages and salaries kind of all over the map. There doesn't seem to be a whole lot of consistency. But the thing that is consistent is if you're good at what you do and you land in a good place, there's always room to move up. So, and sometimes fairly quickly too, right? They want to know that you can handle the workload before they hand you more money. So there's definitely a reward for performance. So don't be intimidated by, oh, that's a really slow starting. That's starting. But there's always opportunity to go up the ladder, right? So.
Awesome. Okay, I have one last question for you guys. Someone asked if you could let them know any related NSCC programs that would kind of get you in the similar field.
yeah, so certainly, so like I said earlier, we work with a lot of different industries. So you could go more of a hands-on. So we're kind of a mix between, we're primarily an office job, right? You're sitting at a desk doing CAD, making drawings, but there might be that 10 to 20% where you're out on the shop floor and not necessarily running a CNC machine. We give you exposure to that so that you understand what is better for designing parts, right? And what the capabilities are for the drawing. But other programs, there's precision machining at Akerley campus. There's metal fabrication at Akerley campus. Here at this campus, there's HVAC technician. There is, a lot of the trades, even carpentry, right? You're designing and making things, right, with your hands. Whether it's reading drawings to do that, or just using the design knowledge and understanding of the tools that you use for that. There's the other side of that where, so for us, we're mechanical. We do also go into like steel detailing. So if you look at, if I was at Dartmouth Sportsplex the other day and looking in the pool area, in the roof, it's hollow structural steel connected to some W-shaped beams, right? We do that type of steel detailing. We work hand in hand kind of with the architectural drafters who are doing, here's the architectural build of that building. Then it goes to, say, RKO Steel or Cherubini or Merid Industries, and they're doing the shop drawings of that steel that then gets shipped out to the build site. That would be us. So the architectural drafting would be similar. And then kind of another step, if you're more into that, if you're more into physics and math and calculus, getting into the mechanical engineering technology program, right? Where you're doing more of that engineering design that I talked about earlier. So we're really connected to so many different aspects. The Aviation Institute, just that's kind of connected to Ivany campus, but not. we're not co-located, but we're connected. You know, they're working on aircraft structural mechanics, right? They're reading drawings. They need drawings to or even their standard operating procedures have very specific, those are made from CAD drawings in order to give those, to make those diagrams and those parts lists, right? So it's a very, that's a very broad question that I hope I gave a satisfactory answer to.
No, that's great. It's for those who are in Nova Scotia, it's 7:08 p.m. And I think I want to thank you guys for being a part of the panel and being a part of answering questions and learning more about drafting design. That's all I have. Do you guys have any other final thoughts or anything else you want to tell the folks who are watching before we wrap it up? No, we've talked about it all. Okay, guys, thank you very much for being a part, and thank you guys for spending your evening with me. I'm going to end it here, and this video will be on YouTube for those who are watching back. All right, guys, take care.
Thank you.
Thank you.